We are living in a growing world. Every second, 4 more people are born, and by the end of my talk will be 1,000 more, which is bigger than today's audience. It is estimated that by 2050 it will be approximately 10 billion people. Now, in order to feed them all, scientists suggest to increase food production, at least by the half. Let's imagine for a second Earth as an apple. A tasty, shiny apple. Not all of its surface can be used for the food production. 3/4 of it is covered by the oceans. The remaining part has mountains, deserts, or living areas, like cities. It might be still too dry or soil poor, so in the end what we came up with this tiny part. About 3% of this apple is the farming land. Not much left in the end, isn't it? That's why looking for a new effective methods of the food production is becoming more and more important in a growing world. One of the most efficient methods that the humans were employing in the past century is by using agrochemicals. For example, pesticides that kill bugs or plants which are bad for your garden. And unfortunately, most of these chemicals are also known to be toxic and cause significant health risks to animals and the human. And that is what we, as a chemist, try to change. Find the new, effective compounds that not only useful for your vegetables, but are also harmless to you. How do we do this? Inspired by nature, we are searching for the natural compounds that has already been used by the plants to protect themselves against the insects or competing plants. Now, once the discovering compound has been found, we're trying to find a way of cloning it, making as much as possible similar molecules in order to increase their plant supporting function. Here at Radboud University, we're using metals similar to gold and silver to do this job. And this is a very fascinating process, which you might think in kind of playing with the Lego. We can add some more atoms to the studied molecule, make it more complex, or take some away, make it simpler. And the metal is just playing a role of transporting these blocks. In this way, we can create collections of hundreds of compounds which we then further test in a greenhouse. I hope we will get a winning molecule which could be not only active enough to support your plant, but is also easily removed from the ecosystem. It might take up to 5–10 years until we bring the product from the laboratory to your garden, but I hope by that time I can bring enough apples to feed you all.